Okay, hi, we are live. Cool. So, welcome back, everyone. I'll just quickly bring in my screen. All right, I'll share it, and you'll be able to see that I'll bring up some notebooks to you. I'll run these notebooks with you. We will try to see how we proceed ahead with it. Okay, let me just start sharing my screen. So, give me a minute. My screen will be coming up live. Yes. So you can see it. We discussed about this dataset that we are using. You can check it once again. So add donor price here. So again, this dataset has input string and the output has to be the predicted price for it. Okay. So we can visualize this. If you see that this will be the string. For an example, how much does this cost to the nearest dollar? ABA 36 gas cooktop with 5 seal burners, tempered glass, and this is the details somewhere around here, right? And price is $405.00, and the output is 405. If you look over here, 507.00. Well, there will be maybe some points over here which might affect the pricing over here, right? This will be the pricing right over here. So this is the idea of that model, that the model will have to extract the price and give us from this given string. Okay, so that's the kind of data that we are working with now. So I'll just give you a quick insight of what is happening here. Okay, so I was trying to utilize Google's Gemma 9 billion model. Okay, and I had already quantized it to some version, like a 4-bit quantized version. Okay, and I loaded it in a 4-bit quantized version, which is pretty slow. But still, on Collab, I hit an error right over here that CUDA is out of memory. We tried to allocate this, but GPU's total capacity is this, out of which only 512 MB is free. So my thoughts were that maybe I could fit in a 9 billion model with 4-bit quantization, but I just fell short of around, you can say, 250 MB of RAM more. Okay, so if at all it was not 14.7, but around 15 GB of free RAM, which I would have got, I would have been able to train a 9 billion model. Okay, but it turns out that I'll have to drop back if I'm using Collab to not a 9 billion model, but something like a 7 billion or 6 billion or 3 or 4 billion will definitely work around over here, right? With the optimized techniques that we have discussed. So let us start off with the first notebook that we have designed over here. Okay, so the very first thing that we are doing here is we are installing the pip necessary libraries over here. Okay, which are like torch vision, and this is like the torch set and request, bits and byte, and transformers. So accelerate is used to work with transformers for uh, it's an optimizer for transformers, and then we have dataset, peft, and matplotlib. Okay, so these are again the libraries that we are loading in here again, as you can see. So these libraries will definitely help us do many important tasks. Like for an example, tqdm right over here will help us design these lines. Okay, like it will help us visualize some things that we are running in around. Okay, so that is one. Then we could have hugging face. So hugging face will help us log in to our account. Then we have like from transformers we have so much, right? We have, if you look over here, we have auto model for casual lm, auto tokenizer. So auto tokenizer loads the correct tokenizers which are to be given to the model. And then auto model for casual lm, well, this is a class. Okay, this is a class which is used to load any large language model, be it your llama, be it gamma or phi. So this is this is a class name, okay, auto model for casual large language model. And then of course we have training arguments and set seed. So set seed is used for reproducibility, right? If you have trained any model, you will know, even if you have done basic supervised models, you will know the concept that we can set seed to ensure that the random operations are giving us the same result, and training arguments are used to load the hyperparameters or settings for that model, right? So this is about it. Then we have PEFT. Okay, so from PEFT we have LoRa config, which will give us that, again, the configuration for LoRa. And PEFT model is nothing but a wrapper of the class of the model which is to be fine-tuned. Okay, so that's a little bit about how, and datasets will help us load the data that we are working with. Now, with that being said, now we have different models I've listed down. You can try around. Okay, maybe we could try 5.3. Let me see if we can get access to Quen 7 billion. Okay, let us just go to Hugging Face and let us see if we can get permission for Quen 7 billion. Okay, because I was not able to directly set 9 billion. 9 billion just ran off from this free trial of Grab. Okay, so this is Quen 2.57 billion, Quen 2.57 billion. Okay, and struct. Let me see if there are any permissions needed for this. I don't think so there are. So maybe what we can do is for base model we can switch to QWEN Quen _2_5. Okay, the username is what my name is, dataset, where the dataset is. Max sequence length, how much the model should produce, 182. Quantization would be in 4-bit. For writing the output, like these are green, yellow, red, and these are colors that I'll be using to write the text in the output. Okay, just for better visualizations. So let me try to run this. It will connect with GPU. Okay, I'll once connect with the GPU and let me run these installations once again. Okay, so it is connecting for now. Okay, it has connected. Let's once run these installations, and once we're done, we will just take not more than 2-3 minutes to install this. So let us wait for it to happen. Yes, good evening all. By the way, you might feel that my energy today is a bit low because I am feeling a bit feverish today. Maybe I happen to travel a lot today between the cold car running in the AC and the sun frequently throughout the day, which is why, I have taken up some painkiller, and I'm just here for the session. So bear with me. My energy might not feel this the way I usually conduct a lecture for. But yes, let us wait. Let us wait for the installation, and we see it's pretty huge actually. Uh, well, not as huge as our models would be. If you have to see, suppose if you are planning to install something like Gemma 9 billion, okay. So the main problem was loading the model over here, right? If you see, loading the model took a huge amount of time. Like this is 5 minutes 40 seconds, 9 minutes, 10 minutes, and 20, and then again 30. So around more than half an hour took to just load the 9 billion model, even for a good internet speed of 33 MB per second or 44 MB per second. And then it went down to 15 and 17 Mbps. Okay, again, these are not our internet speeds. These are again in the collab. These are running in the collab. So this is a brilliant internet speed. But even with that, considering that you are downloading something very heavy like 1, 2, 3, 4, 5, 6, 7, so it's almost like 32-33 GB of model, which we talked about. 33-34 GB of model over here is coming up, right? So let us see what will happen with Quen, because I'm interested to see how much size would Quen take. So my guess are that if we are planning to use something like a 7 billion, it would be really, really big. Okay, something like at least 28-27 GB. Let us try to see if we have a smaller model which we can work around with, something like Gamma 2. Let us see. We have Gamma 2 billion. This is something that we should try to load actually. So let me also introduce Gamma 2_2 billion is equals to, so maybe we can just simply switch to gamma to 2 billion for the sake of demonstration. So gamma to 2 billion is really small model. In fact, it comes in the category of tiny model. So anything 1 billion or 500 million are somewhere around tiny model. So this is tiny to small model, 2 billion model. Okay, not really good at the text summarizations or understanding, not at good at complex tasks, mathematical or understanding tasks, but it can still be used for natural language generation. Okay, that's still a model which can serve the purpose. So we are still running through the installations. What I will do is, let me parallelly pass you these notebooks. Okay, so I'll just go to my Google Drive. Okay, I'll create a link where I will upload all the notebooks. Okay, so remember I told you that day 3 is where you will get all the notes. So this is it. Let me just create a new folder. Let me call it PEFT notebooks. And in here, let me add all the files. Okay, I have uploaded it. Let me give it to the moderator. Okay. Okay, so guys, I have uploaded the link in the Google Drive, and it is right over here in the Google Drive, and this link will be available to you soon in the chats. Okay, and I've uploaded all the notebooks. The first notebook that we covered yesterday, I wanted to show you how we can load different models, how the configurations look like, and where we'll be applying PEFT on it, right? And notebook 2, that what I'm trying to do is, I'll try to show you how you can, okay, the pip has installed. Let me run to the imports, explain to you what imports are, the different tokenizers that we'll be using, and the base model and the HF user. So again, people, HF user, you can change this. Okay, this is my name. You will not get permission until unless you have my HF token to use my name. So use your name, which you would have created yesterday on Hugging Face with the tutorial I showed you, and make sure that in the secret keys you have the Hugging Face HF token available over here. Okay, and use your name over here. Dataset name can be same. You can use, or maybe you can download the dataset from here and use your own name to. You can upload the dataset here and use it under your name. Okay, so we'll be quantizing the model to 2-bit and the max sequence length, which is fine over here. These are a few things that I told you. We will just simply run it. We will load the HF tokenizer, and we will now, this is a function that has been created here to just to visualize you how tokens work. Okay, so for example, I'll run this and I'll show you how does it work. So for an example, if I have to run for 0, 1, 10, 100, 99, and 1000, you will realize that each of the number is converted into in a token, right? And each token has its embedding, something like this. Okay, so the number 0 has a token like this, and number 1 has token like this, number 10 has token like this. So in any large language model, each of the character is converted into a token, and this is just a test example. Okay, just to show you how tokenizers work. Okay, now with this being said, the drive link is in the chats. It is available to all of you right now. So this is a good time to download all the notebooks. All the notebooks will be available to you. You can still not run it in Google Colab even with the free version, because there's a limitation of how much GPU you can use. So maybe one notebook at a day is more than enough. That you can try to run 2 notebooks to the maximum. Okay, you'll not be able to run more than 2, I think, especially notebook 2 and 3 together, or 3 or 4 together. So but still, since we are students and we are learning, and we are learning something which is really cool and requires a lot of money to do it, we are doing it for free, using something which is Google Colab. Thanks to Colab, that we can still manage to do it. The point is that again, the free tier comes with some limitations. So I'll recommend that, rather than taking this project as live hands-on, that you try to run things parallel to me. At least for notebook 2 you can do, or you can try for notebook 3. It is better that you just try to understand these notebooks. Then you have this recorded session with you. Whenever you want, you can just load back and then try to code it when you are actually running a notebook for yourself. Okay, but I'll be guiding you throughout wherever the changes are needed. So for example, I explained you that you need to change HF user. Dataset name can be same, or you can change it. You can load your tokenizer. I explained you how tokens will work. You can create it on Hugging Face and put it in the secret keys right over here. Okay, that's the way to do it. And this is just a function that will explain you how different models work with different tokenizers. So again, this will be your homework or your activity to do. What you'll have to do is you'll have to switch from, maybe currently we have used tokenizer for 5.3 model. Okay, if you see, I'm passing model name 5.3. So if I pass model name as Gemma 2, which is a 9 billion model, you will realize that it will load the tokens. Okay, and okay, and you will see that these numbers will be a little different, or maybe if the tokenization concept is same, it might be same or not. Okay, but again, this will be how different models will work with tokenization concept. Now once it is done, we will simply load the dataset. So to load the dataset, we need a valid dataset path, which I've given you on Hugging Face, and we have load dataset function, which will help us load it, and from there we can load train and test function. So if you again try to look at this dataset, price here, you will realize that this model card has two different splits: 4,000 rows for training and 2,000 rows for testing. Okay, so again, we will be able to load it like this, and I'll just try to show you one of the this sample row. We already discussed how it looks like. From here, the goal is to extract the exact price given in this. Okay, somewhere the price is mentioned and we need it. So that's the idea for it, and we'll prepare our base model. Let me call it now, not just llama. Let me call it Gemma model. Okay, so that's one idea that we are going to do. So to load Gemma, we need to make sure that our base model is set to Gemma 2 billion. Okay, that's fine. So since it is set to Gemma 2 billion, we will simply so we have loaded our data set. Now we have seen the data set. Now we will load our base model in the quantized format. So in order to load it in the quantized format, we will use load in 4-bit quantization and double quantization. That is true. So so this is NF4 is the data format which is used for quantization. 8-bit loading is true. So this is the bits and bytes config that we will be loading in, if it is quant 4-bit or else the 8-bit quantization. So we will create this, and the configuration is set. We will pick the quantization, and while loading the model, we will simply pass the base model here. Okay, into the from pre-trained we will be loading this tokenizer, and we will using padding, and padding is a concept of NLP. Okay, so and from there we will be passing the quantization config over here, which is created over here. Okay, quantization config, you can see. So in the quantization config, if you go here, you will realize that we have set the quantization config right over here. Quant 4-bit is set to true, which means you want to do it in 4-bit quantization. So again, if it is true, it will load this setting, okay, which is 4-bit quantization. If you want to switch to 8-bit quantization, you can either remove this if else loop, or you can simply set 4-bit quant to false. Okay, that's again one idea. And once you have done it, you will be able to load the base model, okay, and the memory footprint for it. So loading it was pretty heavy, especially when I loaded the Gemma 9, which failed to run here. Now if I run it, it will try to load the 2 billion parameter model. Okay, frozen set has no attribute discard. Okay, just a minute. I have to just check, something might have gone wrong in between. Okay, All right. Let me try to disconnect and delete the runtime. Let me change the runtime to T4GPU, which is fine. Okay, now let me try to rerun the ports once again and okay. And connect GPU with backend. Yes, let's connect with GPU. This time maybe the GPU was not loaded correctly. Or maybe the 2 billion configuration will be a little different. So let me switch back to Quen 2.5. Okay. So we can see currently the imports are running back for us with the new setting. And then let me run this part, and this part, and this part, which is fine. You can load the data set. We load the config. We're still on the PEFT. Waiting on for the model to just finish the execution. So execution is still happening. Okay, so yeah, all the executions have finished. So yes, right now let's start to download the dataset once again. Okay, so I might have messed around with few of my runtimes, which is why I'm getting such errors, but you might not when you run it, because I've tested this notebook thoroughly and it should be able to load. Okay, so again, so once we have run through the loading the model, the next idea from here would be to extract the price. So what extract price is supposed to do is it will just simply split the content on price is. Okay, so if in the Python string, if you have run through how to manipulate strings, so dot split function is used to split the string on the given keyword. So wherever we will find a price is dollar, we will split it in the left and the right part on it, and we will take the right part because the value of the money will be the right, and we will replace commas which could be in like 1,000, like 1,000, and values like dollars can be replaced. So we will just simply get a number from regex. We will try to match it and we will return the float. So this will be the extract price function which we'll be using. So if you want to see how extract price would work, so for example, if you're extracting price of 999, you will see the output is 999.0. And for example, if I'm trying to run 99.57, and if I run it, you will realize that this above function helps us extract the price from the given string. Okay, so next is to create model predict. Okay, so this is yet again a very important function for us. So what model predict is supposed to do is that it will simply we will set a seed. So setting a seed is again nothing but it is setting the model to like the randomization of the model will be stopped. Input will be, we will use the input tokenizers and we'll use the attention mask. Then we'll use output from the base model to generate the output. Okay, so we have our attention mask coming in from torch, we have inputs coming in from the tokenizers, and the outputs will be from the base model dot generate. Okay, and once it is done, the response will be again decoded with the decoder, and we will return the extract price. So suppose if this is model predict, and if you are planning to predict for I'll also print say input question is equals to comma, I'll say test at 0 at text. Okay, and then I'll give you /n, and when we run it, okay, so test is not defined. Maybe okay, yeah, so my data loading didn't work correctly. Let me check. Okay, since I was trying to load the dataset name, okay, let me check. If I'm loading tokenizers correctly, this should have loaded the dataset. Let me just quickly debug this. Okay, I'll just check if the dataset can be fixed over here. Okay. All right, maybe I'll try to force people to install datasets once again. Copy. Let's try this time. Okay. Successfully installed. Okay. The following packages were imported in runtime. You must restart the session. I'll have to restart the session to fix it, but I don't want to restart the session because I really want to focus on fine-tuning part. Okay, so I can just skip this. But see, the idea was that I just have to restart my session. Okay, just to make sure that this uh, file cache will work. Okay, like a local file system cache will be cleared. Okay, so that is one point. Now again, you'll if you run this cell, you will be able to see, okay, that this model predict is the main function which is now helping us predict the value. So we have created a class tester to test out our Gemma to 9 billion. And what it does is, predictor is our prediction function that I just showed you, the data that we have loaded, the title, and these are few extra parameters. I told you we have defined colors just for green, orange, and red. So if the error is less than 40 but greater than 20, we will go for it green. If the error margin is in 0.4 to 80, will orange, and it is red. Okay, red means the model completely hallucinated. It hallucinated to a point that it's not all acceptable. Orange is again not very good output for me. It has a decent amount of error into it. Green is something that is good. Okay, green is something that I want. So I have run data point and chart, again a function to create a chart. Run data point will take the data point, it will self predictor is the prediction function. Based on it, it will have ground truth. So ground truth is data point at price, because remember our data set comes with two rows. One is the string and the other is the price in it. Okay, so remember, price column has the actual ground truth. So by using the ground truth, we will be able to find the error, which will be the absolute difference between what the model has guessed and the truth. And using it, we'll be able to define and give it a color map whether the answer is matching the ground truth in green, orange, or red zones. Chart will be used to plot it, and we'll generate a report, and run will be used to run it. Okay, so this is the overall class that we have defined, and tester.test will then run on all 2000 rows. Okay, so once it is running, you will see the output is coming in, and model fails on some parts, like uh, at least on second point it has failed. Okay, truth was $100 and model gave us to $25.11. Okay, giving us an error of $125 right coming in. Let us check if there are any questions coming in. Yes, which language is it? It is Python to begin with. Python 3.10, 3.11. Yes, hello everyone. Just reminder that I am feeling a little low from health, hence my energy is a little low, and I'm not able to give my best at this session. But again, what I'm trying to prove over here is that I have a notebook. This is available to you. It is pinned in the chats. You can see in the chat live. The drive link has it. You can run this notebook on your own. And what is the point of this notebook is to show you the base accuracy of a large language model. Now you can test whichever model you want. Okay, either you can take Phi, you can take Gemma, you can take Quen, you can take Llama, whatever you want. Okay, in fact, any other which is not even mentioned here, make sure it is from Hugging Face, not from any other source, because then the format will not match. And once you have loaded it, this is how the testing function will give you the outputs. So I can see that despite being a good model, you can see many greens, orange are also there, above $40 error, but there are decent amount of reds also coming in here, right? So which is where we will have to, okay, so I'll have to go to runtime, I'll have to manage session, and I have to disconnect everything. Okay, terminate other sessions. Now once I've closed it, I'll have to go to runtime, change runtime GPU TPU TK runtime, and I'll go to, let me just try to change this to Gamma 2 billion model. Okay, this time I just copy this, come over here, change this to 2 billion model. So make sure that the model which you will fine tune, whatever model you want to fine tune with PEFT, you keep the same model over here so that you can compare it later on. Okay, so again, the libraries will be very same. You will realize that we are using almost the same libraries to check in around here. Okay, because most of the case is very similar to what it was supposed to be, right? So that's the idea. Once you have done it, you can just simply go ahead and try to run this installation once again. This notebook was not authorized by Google. Yeah, it's fine. It belongs to my actual main email ID, but that is fine. I can run it on my own over here. So I'll connect this to GPU and I'll try to run it once again. Let it run meanwhile, okay? All right, so this is up, this is running. So I think many of the things remain same in these imports. Something like PEFT is for PEFT. TRL, okay. So TRL is a supervised fine tuning trainer, okay. It is a high level trainer class which belongs to TRL library, okay. It simplifies the fine tuning for LLMs, okay. When we are tuning for supervised tasks, so maybe we have an input column and the output column. So SFT trainer is something that is used to train the model, and SFT config is as a configuration class for it, okay. So that's a class that is something new which was not there in the previous notebook, but apart from it, things are same. I've explained you these parts. So we are using the price dataset to check how the model is performing. That's correct, Tarun. We are using the price dataset, and that's how we were able to run the notebook to give us the output of what the current price is. Yes, Sonal, this is Python programming. So let us just run through pip installs. Let us see how much time it will take. Usually it can take 2-3 minutes more. So as I mentioned that I tried to run through different models. Like I was able to run at least a 7 billion model through this notebook, and I thought that maybe I will take 9 billion as an example for this class. But it turns out that the 9 billion model ran out of memory. And that's one disclaimer I'll give you, that try to keep the model small, at least 7 billion or 8 billion maximum, okay? Quantize it to 4-bit. Only then you will be able to hit through it. Fine. With that being said, let us wait for the installations to finish, then we will run through the import. Let me see if TRL is mentioned over here. Okay, so you will see that we will be using W and B. Okay, so okay, let me just quickly take you to this website. Okay, just give me a minute. Let us finish this installations first. So weights and bias is website we'll be using. Okay, weights and bias. So wnb.ai is the website that we'll be using. So what is this website all about? So it's an AI developer platform to build AI agents or applications and models with confidence. Okay. So how it works is, let us get started with the models. So we can train, fine tune, and manage AI models. Okay. So WNB packages help us train, fine tune, or govern and manage our models, okay, for experimentation. You can also use this for even production or acceleration, okay, like of your project. So you can, it also works with CI/CD. It helps us to reproduce what the models are doing. You can experiment, and this is a really cool tool through which you will realize that we have such great visualizations through which we can see how is the performance of our model. Okay, so we can compare different models. We can compare the training sizes, what happened in each epoch, how the model was converging, and we can see different inference time, training loss, validation loss, and so much more through this GUI. Okay, so this is a really enriched way to see how your trainings were happening. So in order to run through this, we just need to click on sign up. Okay, so as we click on sign up, it is pretty straightforward and simple process to sign up over here. It will not take much. You can use sign up with Google, GitHub, or Microsoft account. I'll use one sample account to show you how we can do it. I'll click on continue. So right over here, it will create an account with my email ID. It will ask me for my organization name. My organization name would be Fractal Analytics. Okay. And username would be this. I'm using it for academic purposes. I agree. This is the only process you will need, people. You just need to use this company name and things like here. Okay. And okay, just let me do Fractal Analytics. Continue. So as you click on continue, your organization URL with this, you can skip it for now. Okay. So what do you want to try first? We will try models. Okay. And in order to try models, we will simply click on continue. And once we click on continue, we will be able to jump into our, you can say, the home page, and you will see our API key for logging into WNB library is right over here. Okay. We can do simply pip install WNB and WNB login and hit in our library. To run a new project, we simply need to use random WNB, and to run it, we can simply use the initializer of WNB. And we have used it in our code, and we can see live metrics, terminal logs, system chats in our project itself if we are running it like this. Okay, so this is really useful. And just copy your API key. Once you copy your API key, go to the secrets, and you can give network access to WNB API key, HF token. These are the two keys that we will be creating manually. Okay, you need to add a key, add a new secret key, and from the add new secret key, write this key name and give this value. So once you've given it, you will be able to see that these are the few things that we are loading in. And once you've loaded, our base model is Gemma 2, project name, HF user is llama dev, and database name is right over here, max sequence fine, run name. Okay, so now since we are running any fine tuning, it is good to give it a run name, project run name, and Hugging Face model name. Okay, now coming back, these are few things that you should specifically care about are the R and alpha and target modules. So again, this is not new. We have covered this yesterday. We know what are we doing. We are setting hyperparameters for our training, and the dropout rate is something like this, and this is quantization. We are using 4 bits true. Now, for how many epochs you can do, right? Ideally, when we train the regular machine learning models, we keep epochs even as high as 100, 200, 50, and so on, right? But since we are running it on Collab, and for now this is a very fairly just a simple demonstration of how we can fine tune. So running more epochs will require more time. Okay, it can take hours and hours, days and days if you hit more epochs. Okay, but so you can do more, but one is fine over here. Now batch size, again, what does this mean? Suppose if I have 2000 rows with me, and if I hit a batch size of 4, which is in a multiple of 2, like 2, 4, 8, 16, something like that, it will take 4 random rows to generate a prediction, and from there it will optimize the weights. So bigger batch size will mean the model can generalize better, but again, hitting it on a free session with 16 GB RAM, batch size has to be very minimum. You can even keep it 2. 4 is the max that you should think of. You can reduce the batch size to free the GPU. Okay, so again, this is a good way to reduce the GPU usage, but it comes with its own cost. So again, I will recommend that this is more important. If you have a good background in machine learning, you will have some fair idea about what epochs and batch size are. But again, I just explained you what they're supposed to be. And then gradient accumulation steps are like, after how many iterations do you want to accumulate your gradient values. Okay, so since we are running a epoch of 1, we have a batch size of 4. 1 is fine. Okay, and learning rate is, this is by default any random value. It can be 0.0001, which is fine, or 0.0015, which you want to keep. Scheduler type, it could be by default cosine. Warm up ratio is, again, like, you can skip it. It is used to run through a pre-training. Okay, and the optimizer we are using is Adam optimizer right over here. Okay, so this is a few of the strategies that we keep for a PyTorch model, any model, that machine learning model. These are hyperparameters for training the model. Okay, now once we're done, we will have steps of 50 and save steps of 2000. Okay, so save steps are how often it will upload to the hub what is happening. Okay, so you can run save steps for 2000 and something like that, and log to WNB if you keep it true. If you keep it false, you don't need WNB credentials. Okay, but since I wanted to give you a fair idea that there are some really interesting tools which you can use. Maybe if you were new to Hugging Face, I just introduced you there. If you're new to this tool, it's a really cool tool to use. It's really good for at least LLMs to track how the training is happening. So you can keep it true. And what does it take? It just takes to simply sign up and use an API key for now. Okay. Again, so once this is done, let me run through this part. Okay. Yes, so I was able to run this. I will load my Hugging Face token and I'll use my WNB key. Okay, our login was successful. WNB API key is configured and was forced to relog in. Okay, fair enough. Now we will load the dataset. So datasets are loaded for now. Okay, and if WNB logs are there, we can simply check the logs. Okay, view project at view run at. So I can simply see what my runs are happening here. Again, this is for my another email ID. These logs are going over there, so we can skip it for now, and we'll set the tokenizer to again 4-bit configuration. This time, since we are using the base model as 2 billion model, if I'm not wrong, we will just quickly check. Okay, frozen set has not been discard. Okay. The installed version of Bits and Bytes was compatible without GPU, was compiled without GPU. Okay, I think the runtime is running without GPU. That's the problem which was happening in the previous one. Let me just check. Manage run sessions. This is fine. Runtime, change runtime type, but it is already on T4 GPU. Again, this is some weird issue which is happening with the collab. It is showing us that we have compiled without GPU support. Let us see how our bits and bytes were configured. Okay, if you go back, all right, this seems fine. Load in true. Let me just have code over and I'll print config. So this is true. Load in 4-bit is true, which is fine. Quantization method is bits and bytes. Okay, well, this is a very strange error, which should not be happening because, okay, this is a warning. Only Intel CPU supported for bits and bytes at the moment. Maybe this is something to do with the disk. Okay, I'll just change the run type to, once again, let me try and save it to this. Let's see if we can. Okay, you cannot currently use. Okay, I realized what is happening over here. Fine. Despite I am running it in T4 GPU, I have exhausted my daily capacity. I cannot currently run the GPU due to the limitations of the free tire. All right, so that's the issue. Apart from it, I have run this notebooks previously. They should not cause this problem. Okay, yeah. So that is one thing because you can see the warning is straightforward over here that these were compiled without GPU. Okay, and without GPU we cannot do this. Anyways, what we can do is maybe let me try to see if I can log in through a different account, and maybe we can run it over there. Okay. So I'll try to reshare my screen for yet another different account. Let me go and see if I can run Colab from a different screen. Okay. Yes, I'll just reshare my screen. Okay. Let me get the screen live again. So I will ask the moderator to just share my screen again, and I'll check if this another notebook that I'm using has the GPU available. Okay, let me just check runtime. Okay, I'm on T4. Let me just share my screen again. Okay. So just be patient, people. The screen should come up quickly. Meanwhile, if there are any doubts that I can address, just make sure that you can ask me. I'll make sure to answer them. Okay, and we just need to install TRL once. So while my screen is coming up, let me just quickly, meanwhile, do the setup part once again on a different collab. Okay. I'll see if the moderator is available. I'll request them to bring my screen up. Okay, just a minute. I'll just ping the moderator that my screen should be visible again. Meanwhile, students, I'm just running through that boring installation, and I'm trying to check if at all the email ID that I have, if it has some free credits left, I'll try to run Google Colab over there. Okay. So by that time, make sure that you do this setup for the weights and bias, the WNB.ai website and Hugging Face, because these are two tokens that we are using, and it's really interesting way to fine tune the models. Okay. So if there are any doubts, if even in the previous notebook that you wanted to ask me, you have notebooks with you. In fact, the drive link is still pinged in the chats. You can download them, you can view them locally, and try to check if there are any doubts. You can ask me for sure. Okay. So I'll have to restart my session. I'll just do that. So if at all any of the notebook shows you any error of import, especially like TRL, you can just simply do pip install TRL. But apart from it, you should skip certain warnings that I'm telling you. Okay. I've noted down those things correctly in the notebook. The notebook are self-runnable. Uh, just I'll wait for the screen to come up. There might be some technical issues with my screen, but if it comes up live, I'll start off from there. Okay. Meanwhile, I'll just reload the charts. Yeah, all good. Okay, dataset name. I'll just connect the dataset once again, which we were using. So let me see if this new notebook is able to, yeah, so the new notebook is able to load the dataset. It means I still have some GPU computation left on this account. Fair enough. Okay. So just hang on, people. I'll just wait for my screen to come up. Okay, there might be some technical faults because of which the screen is not working. Somewhere, the screen is not coming up live. We will wait for it to come up live. So meanwhile, the window is open for any chats and doubts you might have. So this time I'll try to load in the base model of 2 billion model. Okay. All right, I think there are some issues with the screen share. I'll have to still wait for it to come up. Uh, if at all there was a different way to do it. So before the screen comes up, if there are any doubts, people, you can definitely ask me. I am all up for the doubts. We can talk about it. All right. Since there are no doubts coming in, I believe that people are able to follow up with the notebook. So I started loading the model for now. The model is again around 5 GB of file, since this is a 2 billion model, and this should suffice. This should be able to quickly run through the best techniques. Okay. So sometimes you might get few errors in collab, like right now I got an error. Uh, these errors might happen because your GPU allocation is not happening correctly. There are some weird ways collab might produce some bugs. So the good idea is sometimes you can just simply restart the session, okay? And that way you can just reload the GPU. So that works well, okay? So sometimes when you are loading the tokenizers, you're loading the base models, you're using calls like auto model for casual LM, you are loading a LM. At that time, sometimes some different weird errors can come up. And for that, you can just simply try to reload the config, okay? So if you get any import error, like error while trying to quantize or get any anything from the request, right, you can just simply try to reinstall, okay? It might tell you that you need a updated version of bits and bytes to do that. So avoid those errors. You can just simply restart the notebook and that error should be mitigated, okay? So currently we have finished 1 GB of installation out of 5. We are waiting on it. All right, great. So cool. Now you can also see that the maybe there was some technical issues because of the screen went down, but now we have it. We have model 1 of 2 saved tensors which are loading in, and you can see right over here that out of 4.95 GB, I am hitting over here. Okay. Cool. So let us wait for this to finish up. It shows ideally it should take less than 1.5 minutes from now to finish this loading. Okay. Now while it is loading, I'll just quickly walk you through what I've done. So I've done nothing but changed the model for to 2 billion. Okay, and this is the project that we are using. Yeah, and rest of the things remains same. I explained you through that part. I just imported things again. I was getting one error on this, right, because which I had to do pip install bits and bytes when I was trying to run this part of the code. Okay, and when I did some online debugging, I realized that this error which comes up, okay, using bits and bytes 8-bit quantization requires accelerator, or maybe it requires some latest version or something like that. Idea is just start with a fresh environment. Okay, so I just went and on the runtime I restarted my session and it was good with me. Okay, the bug was fixed. So we are doing good. We have covered more than 4 GB, so a little bit more. And then, so let's talk about what is happening in the preceding cells. So from TRL we are setting up the format that we need. Price is dollar. Okay, so this is the kind of format that we want, and we will put the response template right over here with the tokenizer. What this is doing is it is helping the model understand what type of output do we want. Okay, so once we have specified this, okay, the next goal would be to load the LoRa parameters the way we have explained them. So we are not writing anything over here. We are using the LoRa parameters from the config that we have created. And train parameters, well, again, they come from what we have mentioned. If you see acclimation steps, batch size, epochs, project run name, eval size, save steps, okay, learning rate, warm-up ratio, sequence length, everything we have explained on that top. Okay, and once we have done it, we will create a fine-tuning object of the class SFT trainer. I explained you why we are using SFT trainer in the first place. And once we set it up, this is it, students. This is what PEFT is all about. This is the most important cell that you have to see. These are the settings that we will set for PEFT to work, and just a single line finetune.train. What is finetune? Finetune is a class of SFT trainer, and SFT trainer is what we will use to fine tune the model. And once the training is finished, we will save it to the hub. Okay, and on the hub, your fine-tuned your own personal large language model, something that is now your proprietary. This is your own copyright. You will own this if you fine-tune this with your own data set, basically, to begin with. But this will be something that belongs to you. And once this training has completed, this will be your data set and your data model. Okay, so this is about it. Let me just check. Okay, we have finished loading the model. I'll just create quickly a class. I'll set up the LoRa config, and okay, training tokenizing the train data set. Okay, let it finish tokenization. If you remember, these are the 20. We have set a cap to training size. Okay, we can in fact reduce the training size to 1000 or 2000 only. Ideally, we should have for demonstration purpose. Once it is done, as soon as I will hit fine tune, it will start the fine tuning. Okay, so the fine tuning of the model has literally now started. Okay, and if you see, it is learning over here. Okay, and steps and training loss will be printed right over here. So it is running 3 out of 4000, and okay, it could take around 4 hours to finish this fine tuning. Okay, this is what the current estimations are. Well, we cannot sit live for more than 4 or 5 hours, but congratulations to all of you people that we have started the fine tuning of our own model. Okay, so once we finish the fine tuning, you have our notebook 5, which LLM4, I think LLM4 is the notebook that I've given you. That will be your practice notebook where you will evaluate whether your fine tuning did any improvement or not. Okay, so if there are any doubts that you have in this session, you can ask me. If not, I'll say that at least from my side, I have demonstrated how you can start the training. Despite of some difficulties, we were able to reach here. The problem was in the previous browser, my GPU had exhausted for the free tire. Let us just quickly go to the resources, and you will realize that we are hitting a load of 8 GB of GPU. So remember, students, even if you want to do it on local, and if you're thinking that an 8 GB GPU would suffice, you will be on bare you will be barely making it. You'll be hardly hitting it, right? Even with an 8 GB GPU, even for a small 2 billion model of Gemma. Okay, but for 16 GB, it is fine. For 16 GB with PEFT and with a 4-bit quantization, you can go even a little bit high as 8-bit quantization, I will say, because it will consume around 15 GB of RAM. But if you can manage it under the hood of 16 GB GPU, you can still train a 2 billion model with 8-bit configuration, or you can go for 6-bit also. But 6-bit should safely train out on 16 GB configurations. But yes, for a demonstration purpose only, one for your resume, you can put it on your resume that, hey, I have trained open source large language model using PEF techniques such as LoRa, and through it I have learned and demonstrated on Google Colab how we can utilize it. You can maybe go ahead and try to publish this on your GitHub. You can try to publish this on Hugging Face, and you can let other people know. You can shine out that your resume now shows how to fine tune the parameter efficient fine tuning for large language models specifically. And this training is running on, it is going on and on. Let's just go down and see how it is working in. Well, it is still running in nice. Okay, so we can say a lot of data has passed. Currently it has completed 50 steps, and you can see the training loss. So if you realize, we have set a step of 50, so when it has run off the 100 steps, we will get one more training loss. And comparing loss, we'll be able to realize whether the model is converging, whether the model is improving or not. Okay, so that is also really interesting. If there are any doubts, if there are any questions that you want me to answer, this is really a good time. If not, I think we can say we have justified 3 days of marathon. Day 1, what were large language models? Day 2, what is PEFT? Day 3, how we can do it using actual programming or actual code. Okay, so that's the thing for now. Let me just once restart my chat if I'm missing on any chat. Okay, all right, cool. All right, thank you so much, everyone. Bye for now. Good night. Tata, bye bye, sayonara.